Hello folks, we are taking the part 3 video of the exercise 5.1. Here they are asking us to show the multiplicative inverse. In the earlier parts where we were doing the ready reckoner, I had told you that multiplicative inverse of x plus iy is 1 by x plus iy. But that every time it is not so easy to get this. So we go one step ahead. In order to get the multiplicative inverse of x plus iy, it is a shortcut to that multiplicative inverse of x plus iy is x minus iy by x squared plus y squared. Makes our work very easy. So like that we will find out the multiplicative inverse over here. So we could have done it in table form, but then because we are doing it for the first time, we will have it like this. Its multiplicative inverse is, we write the conjugate. Actually, this means the conjugate. Conjugate means what? That I carrying term will change the sign. So you will have 4 plus 3i. That's all. Just change the sign. And x squared plus y squared. So 4 squared plus 3 squared. How much does that come to? 4 squared is 16 and 3 squared is 9. So 16 plus 9, 25. This is a multiplicative inverse. Let's take this also. Root 5 plus 3i. It could come to the conjugate. So root 5 minus 3i by root 5 squared plus 3 squared. So what will this come to? Root 5 minus 3i. This is 5 and this is 9. So that's 14. So root 5 minus 3i by 14. That's a multiplicative inverse. Also, look over here. This is of the form, maybe if you want, you can call it as 0 minus i if you want. So its multiplicative inverse by using the same formula is plus I, because you're taking the conjugate, and you're taking x squared plus, like, so 0 squared plus minus 1 squared actually. That is one itself. So its multiplicative inverse comes to I. So that's about the multiplicative inverse part. You have a last part in this exercise which says to simplify this. You've got to simplify this given expression and get it in a plus ib form. So we'll gradually simplify. The numerator will simplify, denominator will simplify, and see what's coming. Look at the numerator carefully. It is of the form a plus b into a minus b, which is our old friend. A plus b into a minus b always expands as a squared minus b squared. So using that idea, a squared, that is 3 squared, minus I root 5 whole squared. Right away we are getting the numerator because we identified that it is of the type a plus b into a minus b. Now here, of course, because there are brackets in the denominator, we are going to expand it and see what is coming. Minus into minus plus. The root 3 is there getting cancelled. Remaining term stays there. Also numerator 3 squared is 9 minus this is root 5i into root 5i. Root 5 into root 5 we all know is 5 and I squared by root 2i plus root 2i. It is 2 root 2i. Now all this let's solve. I squared we know is minus 1. So what will come? Here will come minus 1. So we'll get 9 plus 5 by 2 root 2i. So that's 14 by 2 root 2i. We generally don't keep roots and i's in the denominator. That's not a standard way of writing. So let's take its conjugate and get everything into the numerator. So probably let's multiply root 2i both in the numerator and denominator without changing the value. When you do that, you're not changing the value because you're doing it both to the numerator and denominator. So what is happening? 7 root 2i is there in the numerator. Root 2 into root 2 we all know is 2. And I into I we all know is I squared. What will happen? I squared is minus 1. So it is 7 root 2 by 2. This minus, if you want, you can carry to the numerator. You'll get minus 7 root 2 by 2i once it gets simplified. So that is about this part. They ask us to write actually in a plus ib form. So maybe you could write it as 0 plus minus 7 root 2 by 2i. That is the a plus ib form. That is a part 3 video of the exercise 5.1. In the next video, we start with the fresh exercise. Thank you.